Future astronauts. Breathe easier. NASA's Perseverance rover makes oxygen on Mars for the first time, a critical component for life support on the red planet. MOXIE is a small gold box that uses electrolysis to convert CO2 into oxygen. The main component of the very thin Martian atmosphere is carbon dioxide. The small device is attached to the belly of the NASA Perseverance rover. During its first test, it produced the equivalent of 5.4 grams of oxygen per hour. At capacity, it could produce 12 grams per hour, about the same as a large tree makes. Future astronauts traveling to the red planet can breathe easy after NASA's Perseverance rover made history by creating oxygen from Martian CO2. The six-wheeled rover is on Mars to search for signs of ancient life, look for water and gather samples of Martian soil and rock to one day return to the Earth. It also has a range of other science experiments, including MOXIE, a small, gold box-shaped instrument that used electrolysis technology to generate oxygen. MOXIE, or the Mars Oxygen in Situ Resource Utilization Experiment, produced 5.4 grams of oxygen in an hour by pulling in CO2 and converting it to the life-giving chemical during its first test on the red planet. This version is capable of producing up to 12 grams of oxygen per hour, or about 288 grams per day. Astronauts on the ISS consume an average of 840 grams of O2 every day. This is a critical first step at converting carbon dioxide to oxygen on Mars, said NASA's Jim Reuter, adding it will make future human missions more viable. The technology demonstration took place on April 20th, and it's hoped future versions of the experimental instrument could pave the way for future human exploration. Not only can the process produce oxygen for future astronauts to breathe, but it could make hauling vast amounts of oxygen over from Earth to use as rocket propellant for the return journey unnecessary. For both rockets and astronauts, oxygen is crucial, says MOXIE's principal investigator, Michael Hecht of MIT Haystack Observatory. To burn its fuel, a rocket must have many times more oxygen by weight. To get 4 astronauts off the Martian surface on a future mission would require 15,000 pounds of rocket fuel and 55,000 pounds of oxygen. Producing oxygen from Mars' 95% carbon dioxide atmosphere might be a more feasible option than extracting ice from under its surface then electrolyzing it to make oxygen, another idea being proposed by scientists.